So what you see here in the screen, it's Kubermatic Kubernetes Platform. This is the version 2.18.2, which is the latest version that as of today, we have out in the market, today being November 29th, 2021. So at a first glance, as you see here, Kubernetes Kubernetes Platform can divide everything via project. So I created a project beforehand in order to have some of the clusters already up and running. What you see here in the screen on the top right is the user option, user settings. As you see here, my user. You're gonna have the alerts for your clusters, and here you're gonna have health up support. You're gonna be taken to the what's new page and API documentation. So you can add a project with any name. Let's suppose I want to call it 2911, and I can just save a project, which is going to be visible over here once you create it. As you see here, it's going to showcase who is the owner, who created it. So let us go into the actual user interface. So when you click in the project, you're going to be taken to this beautiful image. Here in the top left, you're going to have your clusters, cluster templates, which you can create in order to create with just a couple of clicks. You can create any cluster depending the specifications that you have. So as you see here, I created a couple of clusters before. I have one for Packet that it's Equinix Metal now. This is going to be upgraded in version 2.19. I have one for Google Cloud here. I have one for KubeVirt, and I have one for AWS. Here you can see the etcd backups, automatic backups, snapshots, and restores. SSH keys, this can be done for SSH key access, for service accounts. Here you're going to have the members of your organization, which you can add them as owner of the project, editor of the project, or viewer of the project. And this is for whitelisting. You have the ability here to create service accounts, very specific service accounts with tokens that can expire at any given point in time. So as you see here, this account was created 11 days ago, and the token expires in 3 years. It can be refreshed, it can be regenerated, but you can change the token at any given point in time just to allow access to very specific resources. Down below, you're going to have an API window, which is going to take you to the API side of KKP. As I mentioned before, we have a vast array of APIs that you can work with, that you can use to connect to us. So here you got the project ones, default ones, to manage add-ons, which I'm going to get to it in a moment. Admin APIs, methering APIs. So KKP has the ability to measure everything that is happening on your clusters and for you to have visibility of each one of them. This is a feature that is actually available in the Kubermatic Kubernetes Enterprise version, which is very good actually. It allows you to combine all the metrics from different clouds and do analysis of them for financial purposes, usability purposes. Here you got the reports API, data center, and also you're going to have the specific APIs we use to connect to each one of the clouds. So as you see here, we got the Alibaba API, AWS API, Azure API, DigitalOcean, and so on and on. Here you're going to have your MLA stack that comes out of the box with every KKP installation. So you're going to have Prometheus, Grafana, and Loki. So if I go and hit here in Prometheus, so KKP can be used with SSO. We normally use it via Vex. I have it connected in my lab with Google. You can connect it with GitHub or any SSO provider of your liking. So when I connect here, you're going to see here Prometheus. So I don't have anything created on this very specific project that I created. As it is new, there's nothing in here, but you can access it for each one of them. If I go to Grafana as well, You're going to be prompted with the SSO, and you're going to be loading your Grafana instance for the specific project, as you see here, similar to Loki. Down below, you're going to find a link to our documentation, to our forum, to our GitHub, Twitter, and to our Slack channel in case you want to ask us more direct questions or if you need some further support. So let us go into the cluster. So here in the cluster window, you're going to have three options. So KKP has the ability to connect external clusters, so you can have visibility over the clusters. In the upcoming version, 2019, we're actually going to be able to do more than just visibility, and we're going to have the ability to control external clusters. So what you will require is just a kubeconfig file and just provide a name for your cluster to be able to connect it externally. You can create a cluster from a template, as I mentioned before. You can select a cluster from the clusters that I showcased before. You can select how many clusters you want to have. I will create one in a minute. And then you have here the create cluster window. So before I create a new cluster, either from a template or from scratch, I want to show you how this looks like. So here I got a cluster created for Equinix Metal. So when you go inside and you have the cluster already created, you're going to have visibility upon all the good stuff. You're going to have the master version of the cluster. You're going to have your cluster ID, which is the one you're going to get with kubectl, the runtime environments, the cinder blocking for your pods, the cinder blocking for your services, the external CCM migration status, and the region in which was created. You're going to have the SSH key agent, OPA integration. You're going to have all the information that you have here: nodes, CPU usage, nodes memory usage, control plane usage. So you're going to have API, you're going to have visibility upon each one of all the services that you have, right? And you're going to have health checks for each one of them. Down below, you're going to have the event viewer, in which you're going to be seeing what is going on. So as you see here, when I created the project, I got an initial yellow flag, and then the cluster was created. Here you got the role basis access control. So you can create clusters, and this is beautiful when you're working with your white labeling and you want to add specific bindings. So you can add bindings via cluster, namespace, user, or group. So for example, if I wanted to add myself, or let's say I wanted to add a dummy account here, and I wanted to add it as a namespace, I could add the role as a namespace admin, and I can select the very specific namespace in which I want this user to have access to. So if I just want to provide them access to the Kubernetes dashboard, I will add this binding, and this specific user group or account is only going to have accessibility to this specific namespace when they logged in. And this can be used for a lot of different bindings depending what your needs are. Here down below, we're going to have the add-ons window. So add-ons are very specific pieces of APIs that you can add on top of the cluster. So we facilitate this by adding them in a single window that you can add to your cluster. As you see here, I have a cluster autoscaler, node exporter, nginx, NetApp. I have several add-ons that I have added to my initial installation for them to be used. So let's say that I want to use Metal LB. I want to add it. So, there's no place like home. So let's just add home here. I just add the pool range and I just install the add-on. What this is going to do is that Metal LB is going to be available for all of the clusters for all of the worker nodes that are inside this specific cluster. So this is very easy to use. You can install whatever add-on you want, even if it's self-created, you can add it. For example, I'm gonna add here on top of this one, my Helm operator, and I'm just gonna install it. And it's easy as that. You're gonna be able to see it in your machine deployments here. So when we go inside a cluster, we name it machine deployment. So We name it this way because we have a very specific piece that is called the machine controller. So the machine controller, it's the API that we use to connect to each one of the clouds and do our bidding. Basically, create each one of the clusters that you need, each one of the worker nodes that you have. So when we go inside this machine deployments, you're gonna see the main kubelet version, the amount of replicas that you have, uh, the the cloud provider, the operating system, when was it created, and the labeling, including the ID that you will see in normal Kubernetes. You're going to have visibility upon the nodes, which means you're going to have visibility of the kernel version, runtime environment, the instance, node capacity, usage, all the information that you require upon each one of these. Now, you can select to upgrade the system on boot, which means that if you select this one and you want to upgrade the operating system, all you need to do is just restart a cluster and it's going to keep the operating system upgraded every time that you do it. So this is depending how you want to handle the cluster. Now, it's going to come with its own event viewer, as you see down below. You're going to have visibility upon everything that is going on inside the cluster and the worker nodes. So you're going to have here the nodes, creating the instances, the instance provider, all of the visibility that you require is going to be set down below. Now, since we're already here in this version, I'm going to show you how easy it is to upgrade this. So we can edit the cluster and the machine deployment at any given point in time. So we can change the amount of replicas. For example, I want to add 2 more replicas. If I wanted to upgrade or downgrade the kubelet version, I could do that easily here. I just need to select the new kubelet version. You can select the operating system that you want, and you can add any node on the label. So I'm not going to change the kubelet version, so I don't have a very long deployment. I'm just going to add a couple of replicas, and I'm going to save the changes. So that's as easy as it is to add new replicas. So in the event viewer, we're going to see in a minute that the new replicas are starting to be created with the new instance that I selected, and they are created the same way. Now, what if I want to upgrade the complete version of the master? Again, this is very easy to do. So this is one of the main pain points when you work with a lot of clusters and you need to upgrade them all. So here you got KKP, it's always at the latest version of Kubernetes, and you're always going to be having updates available for them. You're going to have a little window here that's going to tell you that you need to upgrade. So you can change the control per version. I am in 121.5. I can upgrade it to 122.2. And I can select to also upgrade the machine deployments with everything. So you can upgrade a complete cluster just with one click. So while it creates a new cluster, so I'm just going to change the control for version. I'm just going to select change version, and it's gonna upgrade the cluster as a whole without any downtime. So while it upgrades, you see the machine controller component is still working, which means that the cluster is still working and you're not gonna have any downtime regarding this one. So while it upgrades, you're gonna see it here in yellow. And let me show you what it does, and we'll come back to this one, how is to create a cluster. So when we reviewed the reference architecture, I mentioned the concept of the seed. And this is what you're seeing on the screen. So I have several cloud providers here. I have Alibaba Cloud as one of my seeds. And as you see here, I have several data centers that I can select to create my clusters in. So I have Alibaba, AWS with all of the regions available, Azure with all of the regions that I have created. So you can select how many regions you want to have, how many you actually need, and you can work with them, depending the provider, of course, and the availability they have. So KubeADM, I have DigitalOcean, GPC as well, Hetznet, KubeVirt, OpenStack, Packet, now Equinix Metal, and VMware vSphere that is normally my on-premise lab. So for the sake of this, I'm going to create one. I'm going to show you how it's created. I'm going to select the Frankfurt region. Be mindful that right now I'm sitting in Colombia, in Bogota. So the cluster, it's very easy to create. You're going to select here a cluster name. You can select any random names. Let's look for one really cool name. All right. Nervous Lamport. All right. And then you have the ability to select very specific network configuration. So you can select IPVs, IP tables. You can select the cinder blocking of your pods and the service cinder blocking. And you can add an SSH key for this specific cluster. Now, here to the right, you will select the version of the master. So I'm going to select 1.19.15, and the runtime environment, I'm going to leave it to containerd, or if you want, select Docker. So on this particular subject, be mindful that we fully support migration from Docker to containerd. You can select your labels. You can do your audit logging. You can do your SSH key agent and OPA integration. Now, when we go into the provider, you have the ability to select several aspects. Actually, you can select here the access key ID, secret access key, the VPC that you want to have, security group ID, route table ID, profile names, and IRN. Now, you can create all of this manually, or you can create presets that your users can actually use. So all of this information is actually hidden from them. In terms, when you actually need to have this, let's say for white labeling, and you just need a self-service portal, you don't need them to have this secret information that can be used for malicious purposes, or for security constraints. You don't want them to have visibility. You just select a preset in which all of this information can be added beforehand. So I'm going to create a Kubermatic. I'm going to select my Kubermatic preset, in which my access key, my secret key, my VPCs is going to be available. I'm going to select next. And I'm going to select now the name of my worker nodes. So let's look for a very cool name. Let's see. All right, Compassionate Gold Stand. That looks good. I'm going to select the amount of replicas that I have. I'm going to create 3 replica. And depending which is your cloud provider, you can select what is the operating system supported. I'm going to create it. I'm just going to leave it in Ubuntu for the sake of configuration. I'm going to upgrade the system on first boot. And as you see here, you can also select a dynamic kubelet configuration. It means that you can actually select how you want to handle this. And here to the right, you're going to see the machines that you have available with the pricing. So this depends obviously on each one of the clouds that you have, how the pricing is handled, and whatever you want to do it. So I'm going to select the smallest one here. I'm just going to select here I'm just going to select this Nano 2. You can select the disk type that you want. Also depends on the cloud provider, the disk size, and you can have the availability zone if you want to have it. So now, if there is no subnet ID or availability zones, you're not going to be able to create a cluster. As you see here, I didn't select one. I didn't create this one beforehand. So this is by design. When we work with AMI IDs, means that you can work, for example, in AWS, you can select a golden image and you can create your cluster based on that specific golden image. For AWS, you got spot instances that we have. We actually support spot instances, and you can select what is the maximum pricing that you want to have on this one, right? So as I didn't create a subnet and ID and availability zone, let us go back and let's create it in another provider, just to show you the difference. So I'm going to go here real quick, and I'm going to select Google Cloud. So for GPC, I have my data center in Frankfurt. Again, I'm going to select the cluster name. I'm going to select 1.19.15. I'm going to hit next. I'm going to select my preset again, just for the service account and the credentials, the networking and the subnets. And I'm going to select again, generated a name. Let's suppose I want to have 3 replicas. I'm going to leave it in Ubuntu, this size 25. The zone, you can select it if there's one available. As I mentioned, you can select the disk size depending on the cloud. Same to AWS. Here in GPC, you got the options that you want to select. the machine deployment that you want to have. So you have all the available options over here, depending which is the one that you like the most. And I'm going to hit next. Then you're going to get a summary here, a beautiful summary of what is it that you're actually going to be creating. And then you hit create cluster. And that's it. That's how easy it is to create a new cluster. So now you see all the services spinning. You got the API server, etcd, machine controller, scheduler, controller, user controller manager, and you're going to start seeing here the events. So while this cluster spins up, let us go back to the one that we had created before. So let us go to our Equinix one. So as you see here, our master version, it's already upgraded, 122.2. This looks beautiful. This is the new version that we wanted. We don't have the upgrade anymore. In the machine deployments, as you see here, we got 3 out of the 4 nodes. Let's go and take a look what happened. Oh, good. We got an error in this one. So as you see here, I had selected 3 or 4 replicas. So what happened in here? Oh, good. It created already. It's giving me the visibility of each one of the events. So let's see. It created the instance. All right. It was just updating the isolation. So now we have all the 4 replicas that we selected to upgrade. This looks beautiful here. All of them are selected here. So this is excellent. Excellent, excellent. Now, if you want, what we can do is let's change it back. Let's change the kubelet version. Let's downgrade it and let's reduce the amount of replicas. All right. So remember that every time when you create this, and this is very important, when you create the cluster nodes and when you change the kubelet version, what KKP is going to do is that it's going to recreate all the nodes. Now, this might sound scary, but KKP, it's never going to allow you to have any downtime in your application. It's always going to have one node up and running to manage the application while it recreates and handles another. So let us leave the amount of replicas the same. Let's just change the kubelet version and let me show you how this actually goes like. So I created one to change the version. As you see, the kubelet version here is changed, and it's already starting to create new, smaller instances here with the new kubelet version. So it's going to create it here, and as it creates one, it's going to be deleted another one. So let me go back to this one in a minute. I want to show you now. Let's review how our cluster is actually looking like. So how is a Google cluster that we just created? It's still spinning up. So now, for the sake of visibility, let us go back to our VMware environment here. So normally, you can create on-premise environments at any given point in time. So this cluster I created without any machine deployments for you to be able to see how this will be added. You can actually create a cluster, have it without any machines and add them before if you just want to have the skeleton to work with. So as you see here, I got a message, failed to create initial machine deployment, the webhook, the machine controller denied the request. So this means that I'm having some issues accessing my specific resources. So let's try to add a machine deployment in here. So I'm going to add one replica, kubelet version, that looks good. The number of CPUs. So now, in on-premise environments, you select the amount of virtual memory or virtual CPUs that you want to have and that you want to pull for Kubermatic Kubernetes Platform to be able to assign to the clusters that you have. So you can select how big your environment is and what you want to be able to assign. So I'm going to leave it by default. And as you see here, I can select the templates. I can create my golden images and select them from this one and create them from this one. So if, for example, I have Ubuntu here and I change to my CentOS, you're going to see my VM template is going to change. For Flatpak, it's going to change. And for Red Hat, if I had one, you will see it over here. So I'm just going to leave it here in Flatpak. And let's say I want to add this machine deployment. All right. So what happened? All right. I'm having some issues with it. So this is for me to show you how it's going to look like when you're actually having some issues in this one. This is going to allow me to actually see what's going on behind each one of my regions. So I was able to create the cluster, but I'm having some issues accessing the specific resources that I have. So in this case, what I will need to do is just go to my VMware instance and troubleshoot why the access is being denied. All right. So this is all done by design for me to be able to show you how the visibility is that you're going to have on this one. So let me go back to the clusters and let's go back to our Equinix Metal. All right. So let's go back to the machine deployments. So it's creating the new cluster. Let's see the event viewer. So found an instance. So it created my new instance. It assigned an internal IP and external IP, and it's being created as we speak. All right. Well, this one is up and running. Let us go to how is it to create and to use cluster templates. All right, so you can create a cluster template a similar fashion as you create a normal cluster. You go through the same steps: provider, cluster, settings, initial nodes, and summary. If you want to create a cluster from a template, I'm just going to select here. As you see here, I have several cluster templates created: Packet, KubeVirt, AWS. So I'm going to go back to my clusters. I'm going to create a cluster from a template, and I'm going to create the KubeVirt cluster, and I'm going to create this from my template. I just want to create one cluster, and you're going to have here the cluster details. You're going to have the provider, which is going to be KubeVirt in Frankfurt. You're going to have the information about the cluster, an auto-generated name, the operating system, admission plugins, settings, all the information that you have, and the presets. Remember, you can have this one as well. This is an on-premise, so you're going to have the amount of CPUs and the memory pool that you have, and the dynamic village version turned off. So I'm just going to create this cluster, and that's it. Very, very quick. This is very useful when you just want to create and destroy your clusters because you're working in a very specific development environment. You can create any cluster template from anything that you want. And you see here, you're going to name it as a cluster instance. It's going to be created on all of the regions and so on. Now, as you see here, our Google Cloud just turned green. So this is beautiful. Now our cluster is running and it's creating our machine deployments. It's creating our worker nodes. As you see here, everything is going up and running. So now, a question of speed. So the deployment usually goes back to how easy, to how fast the cloud provider creates the machine. So this is something that we cannot control. It depends how big the machine is, so just for you to keep in mind. Now, when you have your clusters, you have the ability to create your etcd backups. So you can also have automated backups. So I'm going to select one of my clusters. I can name this demo backup. And you can select the frequency in which you want to have these backups created: daily, weekly, monthly, or, if we want to leave it cron because why losing the habit, right? We leave the cron expression over here and the number of backups that you want to keep, right? So I just want to keep 2 backups, and I'm going to add the automated backup option. So now you see it here. I created my demo backup here in the schedule. I added it here in my own region, and it's going to be creating these automated backups. Now, you can create snapshots as well. You can add a snapshot here. So I'm going to select, for example, my romantic Heisenberg, and I'm going to create it as T1. And I can add a snapshot of this one, which means it's going to take a snapshot of my cluster that I can later on restore if I so wanted. So this is how easy it is to automate and to have this task actually done. Just with a few clicks, you can create all of this and have it ready. Now, let us go here real quick to the members. So you can add a member of your organization. So let me add here, for example, Kubermatic.com, and I can select what group of access I want to provide. If I want to give it full access, all actions, just to the project. So this is very good. You can have users just for the project. So if you have a virtual organization and you handle, for example, several clients, you can create a project by client and assign different permissions to each one of them. And I see here I made a little bit of a typo here. So I'm going to add it as an editor only to be having right access and management of the clusters. So whoops, as you see here, I cannot add this cluster because the user doesn't exist, which means that as this lab is air gap, there's no connection to any other just for my account. I cannot access. So as you see, the security is also very, very tight upon what you have. In order for me to be able to add this, I will need to have the users added into the AD that I have connected in this one. As you saw before, I have this added into the Google domain. So I don't have anything else here connected. You can add it, but if it was, you could add it as a viewer, editor, or as an owner. Now, for the service accounts, you can create any service accounts in here, either internally or externally, which means that the same account that I was not able to add because it was outside, I can create it over here, and I can create it as a project manager, editor, or viewer. So I'm just going to add it as an editor. And as you see here, I'm able to access it without any problems. It has no token. So I will need to add a token. Let's say one, add the token, and you can download it, share it, and this service account is going to be able to access the specific resources that you provided access to. All right, so let me go back to the clusters and let's go back to our Equinix Metal and see how the downgrade is going. All right, so as you see here, a new node with the new kubelet version has been created, 1.20.11. And as you saw before, there was a red one that was deleted. So let us go over here and see what's happening. So it created a new instance, found the instance on the cloud provider. It created a new instance and deleted the other one. So as you see here, it's always going to have the cluster, the worker nodes up and running. There's never going to be any downtime. So which means that you don't necessarily need to plan this along what you actually want to use and what you are, the usability of the cluster. You can do the upgrades at any given point in time without having any downtime. All right, so this is a very brief overview of what KKP capabilities are, cluster templates, backups, and so on. If you want to see here, for example, our Google Cloud cluster, it's still creating the replicas. As you see here, one has already been created, which is beautiful. You're going to get all your upgrades in here. And the cluster that I created directly from my template, as you see here, it's up and running. My KubeVirt is up and running on premise very quickly. 1, 2, 3 clicks, and voila. All right, so this is all. If you have any questions, remember my email. It's in the initial part of this video. You can reach me out directly. You can send me a request via GitHub. And if you want to have more information about our products, you can always go here. You're going to have GitHub.com Kubermatic, and here you're going to have all the community that is working in our products. Remember, we're completely and fully open source. All the repositories and all the good stuff is going to be sitting down here. Now, thank you so much for sitting over this one, and have a great day.